Eighth graders, this is a math lesson for 5-10. You should be looking at pages 249 and 250 as we discuss this lesson. If you remember from last year, there are three different types of patterns that they typically talk about. An arithmetic or arithmetic pattern. The arithmetic pattern is one in which you are adding a common difference each time. Then there's a geometric pattern. And the geometric pattern is where you're multiplying by some number. And finally, there's a pattern that we call neither, because it doesn't fit the arithmetic pattern or the geometric pattern. So let's get into this. Let's take a look at some problems. Calculator will be helpful. Use a calculator on this. It'll save you some hassles. Let's look here. 4 to 12, that could be multiplying by 3, or it could be adding 8, I think, in my mind. Multiplying by 3 or adding 8. How about here, 12 and 20? Multiplying by 3 doesn't work because 12 times 3 is 36, but adding 8 works. What about from here to here? Adding 8 still works. How about here to here? Adding 8 still works. So first of all, what kind of pattern is it? It's got to be the arithmetic pattern, right? So I'm going to write AR. It's got to be the arithmetic pattern, and the pattern is adding 8 each time, right? That's the second part of this. Can you tell me the next number in the pattern? Well, wouldn't it be 44, and then 52, and then 60? Because all we're doing is just simply adding 8 each time. So we've got an arithmetic pattern of adding 8, and the next three numbers are 44, 52, and 60. Let's try this one. 1 and 1/3, 1 and 2/3, 2 and 1/3. Doesn't look like multiplying, it looks like adding. Yeah, it is. It's an arithmetic pattern, and it's an adding of 1/3 each time, right? And the next three numbers in the pattern, I think that's 2 and 2/3, 3, and 3 and 1/3. So there's my answers there. This one's a little tougher. Maybe adding 1, adding 2, adding 3, and adding 4. Is that an arithmetic pattern? No. Arithmetic patterns are only when you add the same amount each and every time. This is an adding pattern, but it doesn't fall under the category of arithmetic because it's adding a different value each time. This would be part of the neither pattern. Okay? It's one type of neither pattern. How would you describe it? You can't really describe it very well like we did with arithmetic patterns, but we can write down the next three numbers in the pattern. This was adding 4, so we'd add 5, add 6, and add 7, and that would be the next three numbers in the pattern. Okay, here's kind of a toughie. What's going on here? If I didn't have the negative signs, I think you would be able to see that it's multiplying by 3. Right? See that? Multiplying by 3 each time. 3 times 3 is 9, 9 times 3 is 27, 27 times 3, 81 times 3. But we do have the negative signs. How does that affect things? Well, here's how it affects this thing. Instead of multiplying by 3, this is multiplying by negative 3. 3 times negative 3 is negative 9. Negative 9 times negative 3 is 27. 27 times negative 3, and so on. So this is our first geometric pattern. And it's a geometric pattern where we're multiplying by negative 3. What would be the next number in the pattern? If we multiply this by negative 3, it would be negative, I don't know. I'm going to have to do it. I got 9, 12. I get negative 729. And then the next number in the pattern would be 7, 2, 8. I get positive 2182. I'm not going to figure out the third one. You folks with calculators, that would be a breeze to figure out the third one. You just multiply by negative 3, right? Okay, let's move on. What's happening here? Bump, 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 bump. The numbers are getting smaller. Do you see that? So we got 1, we've got 5 tenths, which is 1/2. We've got 25 hundredths, which is 1/4. So it's 1, 1/2, 1/4, this is 1/8, and this is 1/16. Huh, that's not an adding pattern, is it? That's a multiplying pattern. We are multiplying by 1/2 each time. If you punch out on your calculator 1 times 0.5, you're going to get 0.5. Then take 0.5 times 0.5, you get 0.25. Then take 0.25 times 0.5, you get this number. Then take this number times 0.5, you get this number. This is definitely geometric, right? And we're multiplying by 0.5. That's our pattern, multiplying by 0.5. And again, I'm not going to figure those out because you can do that on the calculator. But the next three numbers in the pattern would get smaller and smaller as time goes by. Okay, look at this one. What in the world's going on here? Ignore the 4 for now. Just look at those. Isn't it we're getting 5 smaller each time? 5 smaller? This minus 5 is this minus 5 is this minus 5 is this. 4 minus 5, does that equal -1? Yes, it does. This is an arithmetic pattern. But wait a minute, Mr. Panko. You said we're minusing 5. How does that make it an arithmetic pattern? I thought arithmetic pattern, you're adding numbers. You're right. But watch this. Watch this. What if I write arithmetic plus a -5 as the pattern? Plus a -5. Isn't adding a -5 the same thing as subtracting 5? Yes, it is. And that's the pattern here. We're adding a -5 each time. So the next number in the pattern would be -21, then -26, and then -31. Those are the next three numbers in the pattern. So we've got some arithmetic, some neither patterns, some geometric patterns, and now we're back to arithmetic. Okay, let's come over here. Let's look at some more. The top one here. What if I told you to ignore the decimal numbers for a moment? Ignore the decimal numbers. Wouldn't it be 7, 14, 28, 56, and 112? What's going on there? 7, 14, 20, 2.8, or 28, 56, and 112. Isn't that multiplying by 2? Yeah, it is. And if you punch out on your calculators 0.7 times 2, you're going to get this. This times 2 is this. This times 2 is this. This times 2 is this. Another way to think about this is, what if you take any two consecutive numbers like this and this, and what if you divide 2.8 by 1.4? You get 2. Or 5.6 divided by 2 is 2.8. Or 11.2 divided by 2 is 5.6. So this is a multiplying pattern. That makes it geometric. And we are multiplying by 2. That's my pattern. And the next numbers in the pattern would be, I don't know, about 22.4, and then 44.8, and then 89.6, I think would be the next three numbers in the pattern there. I'm probably off the board. Oh, I guess I'm not. I guess I'm not. Okay, let's look at the next one. 17, 10, 3. -4, -11. What's going on here? You might be saying, oh, that's subtracting of 3. But I'm going to call it arithmetic pattern because we're adding. I'm sorry, did I say subtracting of 3? That's wrong. That's subtracting of 7, isn't it? Subtracting of 7. So I'm going to call that adding of a -7 because adding of a -7 is the same thing as subtracting 7. And the next three numbers in the pattern would be -18, -25, and -32. Because I'm still just subtracting 7 or adding a -7. How about this next one? That's a weird one. 1, 0, 2, 0, 3. That's not adding or multiplying. That's going up and down and up and down. If you look at every other number, it's increasing by 1. But if you look every other number on the inside of those numbers, it's just zeros. So that means I think the next numbers in the pattern would be 0, 4, and 0. And I'm going to call that a neither pattern. But I'm not going to put anything here because I don't know what to put there. It's kind of hard to describe briefly. 1, 0, 2, 0, 3, 0, 4, 0. Let's look at the next one. What do you think's going on here? If you said adding, you'd be correct. What kind of adding or arithmetic pattern is happening here? You're adding 1.5 each time. This plus 1.5 is 5. This plus 1.5 is 6.5. This plus 1.5 is 8. So this is adding of 1.5. That's our pattern. And the next numbers in the pattern would be 9.5, 11, and 12.5 when I add those numbers together. How about this one? 124. What's going on there? Boy, it looks like we're dividing by 5, doesn't it? Dividing by 5. But wait a minute, we're not supposed to be dividing. We're either supposed to be adding or multiplying. Watch this, watch this. This is a geometric pattern. And dividing by 5 is the same thing as multiplying by 1/5. But in this case, I'm going to use the decimal form of 1/5, which is multiplying by 0.2. Now, how in the world can I get that? I bet if you take 20 and divide by 100, now notice I said 20 divided by 100, you're going to get 0.2 as your answer on a calculator. Or if I took 4 and divided by 20, I'm going to get 0.2. If I did 0.8 divided by 4, I'm going to get 0.2. If I took 0.16 divided by 0.8, I'm going to get 0.12. Why? Try 100 times 0.2, you're going to get 20. And 20 times 0.2 is 4, and so on down the line. So what would be the next numbers in the pattern? Well, I think the next number in the pattern would be 0.32, and then 0.64, and then 0.128, because we are dividing by 2, or dividing by 5, or multiplying by 0.2. Look at this last one. That looks like dividing by 3, doesn't it? Yeah, it is. It is divided by 3. 6 divided by 3 is 2. 2 divided by 3 is 2/3. 2/3 divided by 3 is 2/9. 2/9 divided by 3 is 2/27. This is a division problem. But we don't call it division. We call it geometric, because dividing by 3 is the same thing as multiplying by 1/3. Dividing by 3 is the same thing as multiplying by 1/3. Remember the rule about division? To divide, you multiply by the reciprocal of the second number. And the reciprocal of 3 is 1/3. So what will be the next numbers in the pattern? I think we would be headed to 2/81 as the next number in the pattern, and then 2/243, I think. And then the next number after that would be what? I don't know, I think it's 729, if my memory's right. Let's try 243 times 392. Yep, 729. Okay. Kind of tricky stuff, but use your calculator to guide you. Thank you, 8th graders.